In this video, we're going to cover the entire section 1.4, learning objectives A, B, and C of solving different equations, variables on one side or multiple sides. Let's first review a question. If I gave you these three equations and I asked, is 4 a solution to them? How could you check to see if 4 is a solution to any of these equations? Well, the most logical way to do it would be to actually put 4 in for the variable and see if it works. Or maybe you would solve it, is another way to do it. Let's actually just put 4 into the equations and solve. So this first one would be 9 plus 5 halves times 4. The question is, what does it equal? Does it equal -6? Well, I'm going to remember to do this. Multiply my fractions straight across. So this is going to be 20 over 2. 20 over 2 simplifies down to 10. And then 9 plus 10 would be 19. That does not equal -6, so no, it's not a solution. I'm going to try letter C. Let's put 4 in for x for this. 3 times 4 minus 11. What does it equal? This problem says it equals 1. 4 times 3 is 12. Minus 11, which equals 1. It does equal the same number that we thought it would equal, so is it a solution? Yes. Okay, let's look at letter B. To see if 4 is a solution to that, I'm going to take the 4 and put it in for y, and we're going to see if that equals -22. Well, 2 times 4 is equal to 8. That clearly is not -22. No, it's not a solution. Now, as we start the formal learning objectives of A, B, and C, we're going to talk about the solving. I'm going to give you an example, and we'll talk about steps that you can use if you like to have steps. Let's write out this one here. And step 1 says this, is to distribute. So I do have a 2 here that I should distribute through. If I do that, I'll get 2x plus 2, and then we have plus 4x equals 12. Step 2 will say get like terms together on each side of the equation. Now on the right hand side here there are no like terms, but on the left hand side 2x and 4x are like terms. So I'll add them together to get 6x, and then we have plus 2 equals 12. Step 3 will say get numbers on one side and variables on other side of the equation by doing this, and that would be by adding or subtracting. So what I'm going to do here is I have the variables on one side, the x is on the left, which means the numbers need to be on the right hand side over here. So I'm going to keep the 12 there. I therefore need to move the 2. The 2 needs to move, it's plus 2 right now. The only way to move it to the other side of this equal sign right here is to not add 2 but subtract 2 from this side and then subtract 2 from over here. That'll give us 6x equals 14. Step 4 then says get the variable by itself by either multiplying or dividing. Okay, again, I'm going to do the inverse operation. So if this is an x times 6, to get rid of times, I would divide by 6. If I do it to one side of the equals 2, I have to go to the other side of the equation over here and divide by 6. And then I would write x equals 14 divided by 6. And we'll just keep it like that for now. The last step, which is not always required on the homework, but you should do this, especially on a test, is check your solution. If I took this answer and put it back in for x, like we just did on the previous slide, if I put it there and there, I would see that this left-hand side should equal 12. So let's formalize more this inverse operation I was talking about. When you have an equation and when you want to cross over to the other side of an equals 2 sign, for example, again, we have 2x equals 6. if I want to move this 2, which is currently on the left-hand side of the equal sign, if I want to move it to the right-hand side of the equal sign, where I actually kind of cross over this dotted line, you have to do the inverse operation. Again, you only do that when you're crossing over the equal sign. So to get rid of this 2, this is 2 times x. This is multiplication. So the inverse of multiplication is to divide. So let me show you. On this, if it's 2 times x, I would divide by 2 and divide by 2. That's where I get that x is equal to 3. Okay. Now don't confuse that with this. What if I had on simplifying an expression? If I said 3x plus 2x equals what? Well, if they're on the same side, you just crunch them together and you say 5x. You don't move it across the equal sign. Here you're just actually getting an answer of 5x. So let's go back up here. If we said divide is the inverse of multiply, then if we're given division and we have to find out how to get rid of that, we would do its inverse. And the inverse of divide, again, is just multiply. Okay, add and subtract go hand in hand. If you have addition in an equation and you want to get rid of it, you subtract. If you have subtraction in an equation and you want to get rid of it, you add. So let's look at this example. Our step said if we have any distribution to do that first, and we don't. The second step said if there's like terms on one side, combine them together. Well, these are all on one side. One's a number, one's a variable. You can't combine them together. The third step said get the x's on one side and the numbers on the other. This is the only x and it's already on the left-hand side of the equal sign, so let's choose to move the minus 11. Remember to move across to the other side of this equal sign here. I want to go to the other side here. To move a minus 11, I would do the inverse, I would add. If I do it to one side of the equals, I'm going to do it to the other. Then I have 3x equals 12. Now the last step is get x by itself. If this is 3 times x, because I have to move this 3 to the other side of this equal sign over here, I'm going to have to cross over this equal sign right here. To move it, it's 3 times x, so the inverse of times is to come in and divide. If I do it to one side, I have to do it to the other. What happens is 3 divided by 3 becomes 1, or just a single x. 12 divided by 3 is 4. Again, I could check the solution if I wanted to. If I put 4 back into here, I would get 3 times 4 minus 11. That's 12 minus 11, which does equal 1, so it works. Now we're going to switch when there's variables on both sides. So in here, again in the steps, there's no distribution, there's no multiplication to happen. Also on each side, there aren't any like terms to add together. That's a variable and a number, a variable and a number. So now all I have to do is to get x on one side and the numbers on the other. I have very many choices for this problem. There's 4 different ways I can start it. I can either have the x's be over here or I can have the x's be over here. It doesn't matter. I'm going to choose to put the x's over here to the left-hand side. So I'm going to keep the 8x there, which means I'm going to move the minus 4x. To move minus 4x, I'm going to add 4x to both sides. And I'm going to line them up with the x's. And then add straight down. So 12x, and then the plus 15 equals 51. Because I chose to move the x first, the x's are together. This 15 here has to go to the other side. To get a plus 15 over, you minus 15. And when you add this together, we are going to get 36 on this side and a 12x over here. I'm almost done. To get x by itself, I'm going to get rid of the 12 times x, so get rid of the 12, which is being multiplied. I divide. And I'm left with x equals 3. Let's look at this one here. Step 1 does apply this time. If I need to, I have to distribute. I need to distribute this 7 through. 7 times 4x is 28x. 7 times a positive 3 is plus 21. Then minus 2 equals 10. Step 2 said if there's like terms on one side, and if you look over here, there's 2 like terms, bring them together. I'm going to bring the 21 minus 2. That'll give me 28x. 21 minus 2, put it in your calculator, 19. Now get the x's on one side and the numbers on the other. We only have one x by itself, so let's keep that one here. Let's move the 19. To move plus 19, I'm going to minus 19 from both sides. That's going to leave me with 28x. 10 minus 19 is negative 9. To get x by itself, I'm going to wrap it up. It says 28 times x, so to get rid of the 28 times, I'm going to divide. And I'm going to have x equals negative 9 over 28 as my final answer. This example here is pretty involved, but let's do it. Again, step 1, do any distribution that's needed. I'm going to have to distribute this 5, and I have to distribute this negative 4. Remember, it owns a sign in front of it, so it's negative 4. Let's do that first. 5 times 3x is 15x. 5 times negative 18 is going to get me a negative 90. Equals 15, and then negative 4 times a positive 6x, negative 24x. Negative 4 times a negative 9 plus 36. If you're struggling with getting any of these multiples, just use your calculator. Now let's combine any like terms we can. Over here there's no like terms, but on the right hand side there is. Let's bring the 15 and 36 together. So 15x minus 90 equals 15 plus 36 is going to be 51 minus 24x. Now bring the x's on one side. Again, I'm going to bring the x's over to this left-hand side, so I'm going to keep this 15x here. So I'm going to move the minus 24x to the other side. To move minus, I'm going to add. This will leave me with 39x minus 90 equals 51. Now the x's all together over here, so the minus 90 has to move. To do that, I'm going to plus 90. I'm going to be left with 39x equals 141. To get x by itself, all I have to do now is get rid of the 39, which is being multiplied, by dividing by 39, and divide by 39. So x is going to be equal to the fraction 141 over 39. If you want some more practice, try this problem. Again, step 1, we're going to have to distribute. A negative times x is negative x. A negative times a negative 1 is plus 1. And then we have plus 10. A negative 3 times x is negative 3x. A negative 3 times a negative 2 is plus 6. I do have two like terms on this left-hand side, so I'm going to bring together the 1 and the 10, and I get 11. This time I'm going to mix it up. I'm going to keep the x's on the right-hand side, so let me move the minus x over by adding x to both sides. That'll leave me with 11 equals negative 3x plus 1x is negative 2x plus 6. Now my x has to get by itself, and it's already over there, so I'm now going to move the 6. Instead of adding 6, I'm going to subtract 6. Left with 5 equals negative 2 over x. To get rid of the negative 2, all I need to do is divide by negative 2 on both sides. And I'm left with x equals 5 over negative 2 as my final answer. I want to show you how to do a little more complicated one with fractions. Again, our goal in the equation is to get x by itself. So you're going to try to get the x by itself, and already it's grouped right here. So first thing they'll say is x is on one side, numbers on the other. The x is already on this side, so I have to move the plus 1/2 by minusing 1/2. That'll leave me with 1/3 x equals 2 minus 1/2. Now remember, on subtracting fractions, you need a common denominator. I can make any whole number a fraction by putting it over 1. The common denominator would be 2, so I multiply that by 2 and this by 2. So I would actually have 1/3 x equals, this side right here when I simplify is going to be 4 over 2 minus 1/2. That's going to give me 3 over 2. Now a nice trick when you're multiplying by 1/3 on this left-hand side, to get rid of a multiplying by a fraction, what you do is you multiply by its reciprocal on both sides. It's pretty slick because here's what happens. This 3 and 3 become 1 and those cancel out. So you're left with x equals. Now you have to remember how to multiply fractions. To do that, you just multiply straight across. 3 times 3 is 9. 2 times 1 is 2. So for this one, the answer is 9/2.